Hi, it's Paddy and Lucas here. We're going to go through our design document for our CA1. So we have a color code throughout our document here, just for blue text in blue. It's stuff that we're still in debate. Green font is just some extra information, and purple font is just to tell you that there's some external sources in a different file. So going to talk about the game attributes. So our target audience of the four types of game players: the explorers, socializers, killers, and achievers. Our game is mostly focused on socializers and killers. As socializers, there'll be chat in the game, and there's a lot of fighting happening in the game. The explorers will be the least focused on because of we've got such a small map, because we want to make the best game we can instead of making a load of boring rooms. Um, so the setting of the game is going to be it's like a high school full of monsters, and the different monsters are different like classes. So like for example, you can see here a teacher would be a werewolf, like a bully type character would be like an ogre or a troll, and they're all going to be in like different rooms and areas in the school grounds which you can interact with. We have a UML diagram we're just going to bring in, talk about the. So for the game, sorry, for the entity attribute, player attributes, each player is going to have a whole bunch of variables. Thanks. A whole bunch of variables. So an entity, which is something you'll see coming up in a few types of our uh, objects, is like it's going to have a name and an ID, and that's so we can log this entity. So it's going to come up for players, items, and enemies. Players have a base stat, which you can see down here. Whoops, yeah, down here is their strength, agility, their name, and their health. And their health is just their current amount, their regen amount, their max amount. Uh, for some of the stuff in the player right now is it's definitely going to be there, but we might be missing some stuff because as you go along, you try to implement your code, uh, implement improve your code. Uh, so we'll move on. The rest of the stuff is that you'll have a social skill, which is a thing that can be used with enemies, so you don't have to fight. Uh, the player has a rank which shows whether they're an admin, a god, or a user. This lets them have different commands in the game. An admin has more commands than a god, and a god has more commands than a user. The user just really interacts with the game. Uh, yeah, the room. The room shows which position the player is in. So on to the item. Item again has an entity, so it has a name and an ID, so we can know which item it is. Uh,
in the database.
yeah, in the thanks for ease. Uh, it again has a base stats, um, because our items will be breakable, so they'll need a health amount as well, and their strength and agility will add to the player. Uh, they'll have a price, which is how much you can buy them for in the shop, how much you can sell them for, and if they're sellable, because some items like keys won't be sellable because they're too important. They'll have a social bonus, so they'll have a social type, and the social type is just an enemy type and a percentage. So this bonus will, for different enemy types, it will improve or decrease the social percent. Here's the enemy types here. The the it will improve or decrease the player's social skill. So when they try to interact with them, they might get a more passive or aggressive uh, fight style from them. And each item has an item type. So whether it's a weapon, armor, potion, or key, just so you can't attack with keys and potions and stuff. Next is the enemy. So enemy again has an entity, which because it needs to be stored, so we know what its ID is and stuff. It has base stats as well because it's gonna be attacking you and you're gonna be killing it. So you're gonna need a strength, agility, health. Uh, it has a social skill which is not a social type. It's just an integer. So when you meet it, if your social skill doesn't match this, they'll be more aggressive. But if it does match it, they'll be more passive. So it's got a drop handler. So when an enemy is defeated, they're gonna drop an item, but this is gonna be dealt with in the drop handler, and it's gonna have a vector of all possible items. And depending on the enemy and the room you're in, this drop handler is gonna figure out what item to drop when you defeat that enemy. And it's so you're going to be able to add in different items from here, and you're going to be able to generate what items for what room. And there's even a seeded version, so if you want to have the same game every time, uh, and then you can shuffle the vector around. Uh, and the enemy has an enemy type. Where is? Oh, it's right here, which we talked about before. Just so when it comes to your social skill, you're gonna know uh, how to handle them, and also the drop handler knows what type of item to drop for. For enemy spawning, there's gonna be a class called enemy handler, which will manage this. So enemy handler is gonna hold all the items and have all like different functions to populate all the different rooms when the player enters. So it's just gonna be a vector of enemies, and you're gonna be able to add different enemies, which will then be used to generate rooms, which again will be seeded if you want to have the same game plan, same enemies for room.
Same
Yeah,
enemies for the room, yes.
yeah, and we just moved in here to the generate room enemies. This is how it works.
I can explain it
Yeah, it's
fast.
to return enemies, isn't it?
So yeah, you will
Yeah.
generate enemies for the room where it takes the number that you want to generate. So for example, you take three enemies you want to generate. It will create a vector of enemies that you will return from the function, and then it will generate a random number which will be stored in this integer. And after you generate random number inside of a loop, it will generate that many times, and each time it will generate a different number, and then it will return the vector filled in with the enemies that are random.
So the map is basically a vector of the rooms. It holds all the possible rooms in the map. You can just see here's our like layout that we're going to be following. Uh, these rooms EV have events in them. There's standard rooms where you can fight enemies. The common room is similar to a fight room, except there's no fighting in it. It's just a room, a peaceful room. And then shop rooms is where you can buy and sell some items. So yeah, here's some pseudocode for populating the map. It takes in a vector of rooms, and for each of those rooms, it will connect room exits to the other rooms by populating some pointers. Okay, so the room has an entity in it again. So we have an ID and a name. It also has a class of exit or a struct of exit. Sorry, that is populated by northeast, south, and west. We have int written down here, but what we've changed to pointers so we can point to rooms easier, to other rooms. It has a vector of enemies, which will be populated when the player enters the room. And we have a vector of items, which will be populated if any enemies are defeated. They'll drop some items. It has a room type, so you know if it's a standard, common, event, or shop room, which we just talked about. We were talking about implementing a more uh,
Complex.
complex version with using interfaces and models. Oh, sorry, using concepts and models. But I think we've decided to just go with uh, using enums and
Base class.
yeah, and base class. Thanks. So the combat in the game, the enemies in the game are neutral initially. So when you step into a room, they're not going to attack you. Uh, you have to challenge them, or you have to act or socialize with them. And if you're unsuccessful or poor at it, they'll attack you. Um, so it's done time based. So you can only attack every few seconds depending on your agility and the weapon you're carrying. So if you're carrying a large weapon, you'll be slower. Um, but once you do attack, it calls fight enemy, and fight enemy just checks. It does a random check depending on your agility to see if it's actually hit the enemy first, and it uses your agility and their agility to calculate. It's currently weighted at about you hit about 70% of the time, and if that hits, it will inflict damage. We'll scroll down to inflict damage, which is here. You just take away. Sorry, it goes to calculate damage first. Sorry. So what it does is, if your strength and their strength are equal, it just takes your strength away from their health. But uh, if they're not equal, what it does is it does a divide. So if your strength is 5 and their strength is 10, you're only going to do half the damage that you should do. But if yours is 10 and theirs is 5, you're going to do double the damage that you should do, and then it will inflict the damage. And then it will just check if the enemy is dead. So if their health is less than or equal to 0, it'll just return true, and it will tell you that you killed the enemy. And now I'm just going to pass you on to Lucas to talk about the commands.
Okay, thank you, Paddy. I will talk now about the commands. So commands will be available for the players, and they will be changeable also, and you can you can make your own shortcuts. So you can see here for a user we have a basic commands as attack, so he can attack enemy, pick up, so he can pick up drop, and so on, so he can go north, east, southwest, so also quit the game. So a few that we added in is a shorthand, that is for changing the command shortcuts, and we might have an edit stats command if you want to redo or reallocate the player statistics from scratch, which is still in debate. For a god, of course, you can kick, announce, and all the commands that the user has. Admin, we might have a save where admin can type save and he can save the server. Also, this is still in a debate. For a connection, we will use a telnet. That's how the player will connect to a game. And that will be transferred to a thread manager, which will be processing the connection queue. And there is some snippets of a code. Also, all of the code snippets are available in this folder. So for a runnable thread, we have this runnable thread class, which is just a standard thread, which is just the wrapper around the standard thread, and has a boolean which is atomic, whether you want to stop or not stop the thread. And it will execute one function which is send and receive in a thread. And now if I go into this function, as you can see, I will pass a queued sockets, which is just the data sockets which are being connected as a new users are connecting. Then I'm going to check if I stop my thread, and then I'm going to check if the data sockets are empty. And if they are empty, of course there will be something like a notify one thread when you add a new data socket into your data set. But for this example, I just implemented it with a standard sleep, so I put the thread into a sleep. Otherwise, if you are successful and you have some data sockets in your set, you're going to remove one and process it, and you create a connection from that data socket. And then you're just going to go into a while loop, and you're going to be sending and receiving on the connection. Next is, because we will use in a multi-threaded system, we will need a log, which will be used in a log guard as well. So not there cannot be, let's say, 20 threads writing into the same file at the same time. So they will have to acquire a log. For our queued sockets, which is just a vector of my data sockets that are being connected as the players are coming, is the class that implements also mutual exclusion for the removing, adding, and checking if the vector is empty. Now for our logger, we will use a basic lib logger, and we will use it for a chat log. If the players are sending messages which are not appropriate, it can be checked in a chat log. Then there will be a user log, so you keep a track of what the users are doing, and the error log, whether there was some exception thrown, there will be logged. Now this is still in debate. We were thinking about using database with Postgres SQL um, instead of using database that is provided in the game. For a server crash, we will use an autosave function which will be timed. So there will be a timer, and each 5 seconds the timer, each 5 minutes the timer will be refreshed, and all of the files will be saved, and then the timer will be resetted. For our parser, we will implement the parser class, which will hold a vector of commands that are all available commands in my game, and we'll have a simple functions as a parse and execute, and add command to my all commands. What this will do, I will explain now in a second, but I explain what a command is. Command is another class, and this will hold just the command. For example, you see now there is empty command in the braces, but there will be an attack, and then the shortcut will be A, and a function which will be executed as you are calling a command. And the function is a standard function, and the function will be bind to parameters, so it will be always void, so you can have any functions you want inside of the command, because you will be binding them before you pass them into this class. Now for execute command is simple, you just call .mexecute command. Now we will have maybe more functionality, but for this demo we just implemented that it implemented this class with regex, and it will check if there is, for example, \b attack \b in a sentence, which will then parse it and execute the function that we stored in this mexecute command. And this is the function for a parser, which is, as you can see, really simple loop through all of my command, and if I found any in a sentence, execute it. For a game architecture, now the different handlers we will be using is a login handler. So as a player login through his telnet, he will be assigned to a login handler, as it will handle all the incoming connections. Login handler then passes a player to the game handler, which automatically, if the player is new, will pass it to the training handler. If not, he will stay in the game handler. Protocols used, we will use a TCP protocol, because we want a reliable connection, and this is not a multiplayer shooting game, so we don't need a massive amount of packets being transmitted through the network. For the functions use, from a basic lib, we will be using basic lib logger. Maybe it will be renamed, but the functionality will be of a functionality of a basic lib logger. And then we won't use basic lib random. We will use a functions which will use a random device, Mersing twister, and a uniform distribution. These are the functions for randomizing which we will use. So it's like a get random integer with seed, get random integer, and a crypto secure random as well. Also, we won't use basic lib time. We will use a standard chrono library, and for instead of basic lib, we will use a standard thread library. Thank you for listening.